Good morning, students. Today we are going to discuss the problems related with the fins. First of all, I am going to read the problem. Then we are going to discuss which things they have mentioned in this problem, and last we are going to find out which thing they require. Okay. Now, first problem: a metallic plate is maintained at 250 degrees Celsius. A 2.5 centimeter diameter aluminum rod protrudes 10 centimeter from this blade. Rod is exposed to the atmosphere at 20 degrees Celsius. When H is equal to 15 watt per meter square Kelvin, take thermal conductivity is 200 watt per meter Kelvin for aluminium, assuming the rod as a fin insulated at end, calculate heat loss by rod and also calculate efficiency. So in this problem, they are saying that it is a metallic rod and we have to consider it as a fin. Okay, so we are going to draw the figure of this metallic rod fin. Okay. Now we are going to write down the given things. A metallic plate is maintained at 250 degrees Celsius. So we are writing U is equal to 250 degrees Celsius. Then a 2.5 centimeter. So diameter they have mentioned. D is equal to 2.5 centimeter. We have to convert it into the meter. So it becomes 0.05 meter. Next they have mentioned aluminum rod protrudes 10 centimeter. So they have mentioned length also. So we are converting it into meter. Next, rod is exposed to a atmosphere. Atmospheric temperature they have mentioned TA is equal to 20 degrees Celsius. Next, they have mentioned H value, that is convective heat transfer coefficient 15 watt per meter square Kelvin, and thermal conductivity K is also mentioned, which is K is equal to 200 watt per meter Kelvin, and the plate is maintained. We have written all these things. These are the things they have given in this problem, and they are asking to find us calculate heat loss by rod and the calculate the efficiency. Okay, so whenever we have to find the efficiency how we are going to find? we have the formula efficiency for the fan is equal to tan H ml upon ml. Okay, so we know that the efficiency formula for the fin is tan hyperbolic of ml upon ml. So in this problem they have given all the things. Only we have to find first value of m. Okay. How we are going to find this value of m? We know that m is equal to under root hp by k. So we are writing here under root hp by k. Okay. So in this formula they have given the value of h, they have given value of k also they have mentioned. Just we have to find first perimeter and cross section area. Okay. So cross section area AC is equal to 5 by 4 d square. Okay. Diameter they have given 0.025. So we are going to substitute this value in this equation. 5 by 4 into 0.025 square. So value becomes 4.9 into 10 raised to minus 4 meter square. So we have calculated cross section area. Next we have to find perimeter. So what is the perimeter of this circular rod, which is pi into d. After substituting all the values, pi into 0.025, we are getting perimeter 0.078 meter. Now we have found the value of cross section area and perimeter. It is easy to find the value of m. So we are going to substitute the values. M is equal to under root h 15 into perimeter 0.078 k 200, then cross section area 4.9 into 10 raised to minus 4. So we got the value of m 3.46 per meter. Okay. Or we are saying it also we can write per meter. So value of m we have found. Now we are going to substitute this value in this equation. So in this equation, value of m we have found, length they have mentioned in the problem. So efficiency is equal to tan of hyperbolic of 3.46 into length 0.01 upon 3.46 into 0.01. So efficiency we get 0.996, which is equal to 99.6%. So in this way we have calculated the efficiency of a field. First see what we have done. We have first plot the given problem in the diagrammatic base. So this is the base of the field. This is circular rod which we are considering as a field, and we are writing the given things. Base they are given 250 degrees Celsius Then surrounding temperature 200 degree, sorry, 20 degrees Celsius. Thermal conductivity of this film 200 watt per meter Kelvin. They have given diameter, they have mentioned, length they have given, and convective heat transfer coefficient is mentioned. And they are asking you to find us the efficiency. So to find the efficiency, we have the formula for the film. Efficiency is equal to tan hyperbolic ml upon ml. So we have to find first value of m because length they have mentioned. So for calculating value of m, we will have the equation m is equal to under root hp by k. So in this formula, area we have to find and perimeter we have to find. So we have calculated area and perimeter. So we are substituting the value of cross section area and the perimeter, and they are given in the problem value of h and k. So in this way we have calculated value of m. Once you got the value of m, you can substitute the value of m and the length in this efficiency formula. You got the efficiency of that rod which works as a fin. So this is the first problem related to the fin. Next problem we are going to see a steel rod whose thermal conductivity is 30 watt per meter degree Celsius, 1 centimeter in diameter and 5 centimeter long, protrudes from at wall which is maintained at 100 degrees Celsius. The rod is exposed to environment with temperature 30 degrees Celsius and convective heat transfer H is equal to 50 watt per meter square Kelvin. Calculate fin efficiency, temperature at the tip of fin and rate of heat dissipation from the base of fin. Assume insulated tip condition for fin analysis. Okay, they have mentioned that the tip of the fin is insulated. Now we are going to write the things they have mentioned in this problem. First, they have given a steel rod whose thermal conductivity K they have given 30 watt per meter degree Celsius. Next, they have given diameter D is equal to 1 centimeter, which is we are writing, we are converting it into meter. Next, 5 centimeter long. So L is equal to 5 centimeter, which we are going to convert into meter. Next, temperature of the base. Temperature of base maintained, they have given TB is equal to 100 degrees Celsius. The rod is exposed to environment with temperature 30 degrees Celsius. So we are writing temperature of environment as a 30 degree Celsius. Next, they have given convective heat transfer coefficient, that is value of H, which is 50 watt per meter square Kelvin. Next, they are finding us fin is insulated. So when fin is insulated, they are asking you to find the efficiency. First, they are asking you to find calculate fin efficiency, temperature of the tip of the fin and rate of heat dissipation. Okay, so all these values we have to find. So for calculating when fin tip is insulated, We have the formula Q is equal to MAK theta of B tan of hyperbolic of ML. Okay. So in this formula we have to calculate the heat dissipation by using this formula, but we require value of M, value of cross section area, then K, thermal conductivity they have mentioned in this problem. Theta B we can calculate, and tan hyperbolic of ML. So first we are going to calculate value of M, which is equal to under root HP by K. Again we are going to substitute the values. H 50, perimeter that is pi into d, diameter they have mentioned 0.01, K, value of K they have given 30, area we have to find 5 by 4 into 0.01 square. So after substituting the values we got 25.82. So this is the value of M we find. Next, once you got the value of M, you are going to substitute this value in this equation. So Q, so this is the first case we are considering when 20 piece insulated. So Q, we can substitute the values M, that is 25.82 into area 5 by 4 into 0.01 square into K 30. Next, theta B we have to find. Theta B, that is the temperature of the base and environmental, which is 100 minus 30. Then tan hyperbolic, value of M 25.82 into L, which is 0.05. So we have substituted all the values. When we solve this equation, you can see we got Q is equal to 3.66 watt. Okay. Now they are saying that first calculate the amount of heat transfer. Okay. So we have calculated 3.66 watt. Next, they require to find us deep fin temperature. Okay. So at the end of fin, deep temperature which we are considering so see theta minus theta b is theta upon theta b, which is equal to cos hyperbolic m into bracket L minus x upon cos hyperbolic ml. So first theta we know that it is temperature at the end, temperature of infinity. Theta b we have just taken theta b minus T infinity. Okay, cos hyperbolic ml, and this whenever we solve it, we got cos of hyperbolic of ml. Now we are going to substitute all the temperatures. T infinity they have mentioned here. We can substitute temperature of the base they have mentioned, and value of m we have find, length they have given. So we can substitute all the values. Temperature of the base 100. We have no need to convert into the Kelvin because here temperature difference we are taking. So which is equal to 1 upon cos of hyperbolic of 25.82 into length 0.05. So after solving, we got temperature at the end of the fin is 65.8 degree Celsius. Okay. So next they are asking you to find us fin efficiency. Again, efficiency formula we have tan of hyperbolic of ml upon ml. So in this formula we can substitute the values tan of hyperbolic and 25.82 into length 0.05 upon so efficiency we found 0.666, which means 66.6%. So this is the efficiency of the fan, 66.6%. And last they are asking you find the temperature, find the Q base. Here we have found the amount of heat transfer at the end of the fin. Now they are asking us find the amount of heat transfer from the base of the fin to the fin. Okay, so we can calculate H A theta B. So H 50 area pi by 4 into 0.1 square theta B, which is 100 minus 30. So this gives you amount of heat transfer from the base (0.2748 watt). So this much amount of heat is transferred from the base. See, we have found they have given a fin base. Okay, whose rod is circular rod again we are considering, and they are asking you to find each and every element in this problem. They are saying calculate the amount of heat transfer from the base to the insulated tip to the surrounding tip and to the surrounding. Next they are asking you to find us temperature at the end of the tip. Next they are finding efficiency of that fin, and lastly they are asking you to find how much heat is transferred from base of the fin to the fin. So for calculating fin tip insulated, we are using formula Q is equal to MAK theta B tan hyperbolic ml. So again, value of M we have calculated under root XP by KA, and remaining all values they are mentioned in this problem. So we are substituting in the equation, and we got amount of heat transfer from the tip end to the surrounding, that is 3.66 bar. Next they are asking you find the tip end temperature. So in the tip end temperature, you know this formula we have derived theta upon theta b, which is equal to cos hyperbolic of m into bracket l minus x upon cos of hyperbolic ml. In this formula only unknown, we are modifying this formula, that is tip end temperature minus surrounding temperature upon tip base temperature minus surrounding temperature, and cos hyperbolic m into bracket l minus x upon cos of m minus l. We are substituting the values, and we are getting the temperature at the end of tip of the fin, which is 65.8 degree Celsius. Next we have calculated efficiency. Again same formula, tan hyperbolic ml upon ml. So in this formula we have substituted the values, and we get efficiency 66.66%. Next they are asking you to find out that how much amount of heat is transferred from fin base to the fin. So we have the HA delta T, that is the theta B we have taken, H value they have mentioned, area we can calculate pi by 4 d square, theta B 100 minus 30. Okay, because the base temperature they have given 100, surrounding temperature they have mentioned 30. So after substitution we got Q base is equal to 0.2748 bar. So we have calculated all the values in this problem. So today we have discussed two problems. In first problem we have calculated efficiency of the fin. In second problem we have calculated first thing, that is the how much amount of heat is transferred from the tip of the fin to the surrounding. Next second we have calculated temperature of that fin tip, and third things again we have calculated the efficiency of the fin, and lastly we have calculated the amount of heat transfer from the tip fin base to that fin. So these are about today's lecture. Thank you very much.